As the threat of war intensifies, the United States, a nation at the forefront of technological advancement, is preparing to enhance its defense capabilities both in the air and at sea. This country has secretly tested its news, an extremely dangerous laser system, on one of its most formidable aircraft carriers, transforming the sea behemoth into a highly effective war machine. What makes this laser system exceptional? How does it transform the aircraft carrier into a formidable force on the battlefield? Join us as we explore the mind-blowing capabilities of the U.S.'s recent war beast. After years of research, the U.S. Navy is finally nearing a cost-effective solution to defend against threats at sea from drone swarms and anti-ship missiles that have been increasing these past few years. In the third quarter of fiscal year 2022, the Navy received its first HELIOS system from Lockheed Martin. This high-energy laser is capable of directing over 60 kilowatts of energy at targets up to 5 miles away. It is being installed on a Flight 2A Arleigh Burke-class destroyer that is currently being upgraded. Laying emphasis on the importance of its production, Rick Cordero from Lockheed Martin revealed that the HELIOS defense system stands to improve the ship's combat effectiveness, helping to deter future threats and protect sailors. It also provides a strong foundation for developing advanced laser weapon capabilities. According to Navy budget documents, HELIOS is part of the Navy's laser family of systems, which is planned to be the base for gradually increasing laser weapon capabilities. For the 2023 budget, the Navy requested around $35 million for this family of systems, with the first system expected to be in use at sea during this period. The system doesn't just help to improve defenses against surface threats, but also fill gaps in counterintelligence and surveillance. It can dazzle and destroy unmanned aerial systems and combat fast, small attack boats. While laser defense systems are cheaper and have unlimited ammunition, they can be affected by weather and can only target what is in their line of sight. Conventional weapons will still be needed for larger or longer-range threats. Regardless of limitations, this technology represents major improvements over current systems for dealing with drones and anti-ship missiles. According to a Congressional Research Service report from August, surface-to-air missiles and Gatling guns are not cost-effective for shooting down cheap drones and require extensive reloading, which involves traveling long distances to reach a safe zone. The report, Navy Shipboard Lasers, Background and Issues for Congress, laid emphasis on the fact that China has many UAVs and anti-ship missiles and is capable of producing even more. This could make it expensive for the Navy to defend itself effectively. Tristan Sauer, a land domain analyst at Global Data, highlighted the main concern as how to target, track, and neutralize potential swarms or saturation attacks by small, unmanned vessels like micro-UAVs or small surface vessels. As using drones alongside manned platforms becomes more practical, it is spreading across the battlefield, even in countries with limited resources. For this specific reason, laser weapon systems are useful here because they are very cheap per shot and have a large supply of ammunition. This would help to counter the aerial threats in a cheap way. The Russian invasion of Ukraine has shown how a shortage of munitions can be a major problem. Some defense companies have struggled to keep up with production while also dealing with supply chain issues from the COVID-19 pandemic. Sauer pointed out that laser weapons need very little energy to produce significant effects, making them crucial for maintaining operations, especially in intense conflicts. The earlier version of the solid-state laser system, known as AN/SEQ-3 laws, was installed temporarily on the USS Ponce. However, it had trouble targeting very small objects, like the smallest drones. Due to various operational issues, it was not produced in large quantities and was later replaced by the high-energy laser with integrated optical dazzler and surveillance. Despite its operational issues, the laser system showed its potential. What were the capabilities of LAWS defense system? Let's check out the features of the earliest prototype of close-range defense against small drones and boats. Designed to target drones and a mock small boat, this defense system uses an infrared laser beam that can be adjusted to either destroy a target or just disable its sensors. One of its benefits is the low cost per shot, as it only needs energy to fire, unlike traditional weapons that require ammunition and take up space. HELIOS is meant for dealing with less advanced threats. It can be set to low power to temporarily blind or distract a person without causing harm, or high power to damage sensors, burn out motors, or destroy explosives. It can shoot down a small drone in just 2 seconds and can quickly disable small boats by targeting their motors. It's designed to hit the platform rather than individual crew members, but it can also destroy rockets on board. For larger targets like helicopters, HELIOS can damage key parts to bring them down. In 2010, Kratos Defense and Security Solutions was given an $11 million contract to help the Naval Surface Warfare Center develop a laser weapon for the U.S. Navy. This system, called HELIOS, was tested in May 2010 by using a radar system to track a drone. As earlier mentioned, the HELIOS was installed on the USS Ponce in 2014 for a 1-year trial. The Navy also spent about $40 million on developing and testing this weapon over 6 years. The HELIOS is guided by the Phalanx CIW's radar and has a range of about 1 mile. Its power is estimated to be between 15 and 50 kilowatts, enough to target small aircraft and fast boats. One of the reasons the Navy is interested in laser weapons is because they are cheaper to use, costing around $1 per shot, while traditional weapons like missiles can cost thousands. Lasers have been tested since the 1980s, but older versions were not suitable for ships. This defense system also uses 6 commercial welding lasers that focus on the target together. In tests, it produced 33 kilowatts, and future versions could generate 60 to 100 kilowatts, capable of destroying fast boats, drones, planes, and missiles within a few miles. HELIOS was envisioned as a short-range defense system, mainly against drones and boats. However, more powerful versions have been developed. In late August 2014, the HELIOS laser weapon was deployed on the USS Ponce in the Persian Gulf with the U.S. Fifth Fleet. Its purpose was to test how well it works in a marine environment with challenges like heat, humidity, dust, and salt water, and to measure its power usage. The HELIOS can adjust its power level to either fire a harmless beam to warn a suspicious vessel or a stronger beam to destroy a target. The weapon's range is classified. Although Iran has threatened to block the Strait of Hormuz with small boats, which the HELIOS can handle, the system wasn't specifically designed for use against any one country. In September 2014, the HELIOS was declared fully operational, allowing ship commanders to use it for self-defense. According to international rules, it can't target humans, but it can be used against drones, helicopters, and fast patrol boats. The Navy released videos showing HELIOS disabling a drone, exploding a grenade, and destroying the engine of a small boat. The system has exceeded expectations and is very cost-effective, with each laser shot costing only 59 cents compared to expensive missiles. The HELIOS uses commercial laser parts and special Navy software, powered by a diesel generator separate from the ship's main power system. This makes it highly efficient. It's mounted on the USS Ponce's superstructure and can also be used for surveillance, with sailors comparing its abilities to the Hubble Space Telescope. Sailors trained with it daily, using a simple flat screen and a controller similar to a video game, making it easy to operate. The system performed well in tough weather conditions like humidity and dust storms, though it wasn't tested in severe sandstorms, as threats would also be unlikely to function in those conditions. The Navy is considering deploying it on other ships, and due to its strong performance, the HELIOS stayed on the USS Ponce for as long as the ship remained at sea. After reviewing several ship types to see which had enough space, power, and cooling, The Navy decided that once the USS Ponce was decommissioned in 2018, the HELIOS was to be moved to the USS Portland for more testing. The system will use space and power connections meant for a missile launcher, with the laser mounted on the deck. Since it was just a trial, the HELIOS was not fully integrated into the ship's defense system. Unfortunately, the HELIOS didn't go into mass production because it had some issues as a prototype. These included bulky capacitors that charge slowly, trouble tracking small targets, and difficulty combining the 6 lasers into one strong, synchronized beam. These limitations were resolved by the HELIOS. In January 2018, the Navy signed a $150 million contract with Lockheed Martin to build 2 HELIOS units, with one planned for the USS Arleigh Burke and the other for land testing. 4 years later, the HELIOS system was delivered to the Navy. This defense system is deemed special because it is designed to fix some of the issues with earlier laser systems. Unlike older models that needed extra energy sources, HELIOS uses the ship's existing power for continuous operations, according to Lockheed Martin. This new system has significant advantages over previous lasers. For instance, the older HELIOS system could only reach 30 kilowatts of power and wasn't meant for long-term use. The HELIOS system is being installed alongside an upgrade of the Aegis weapon system at the Navy's facility in San Diego. The Aegis system, which has been in use since the 1980s, is getting modernized by Lockheed Martin for destroyers and other ships. While the Aegis system is being upgraded, the HELIOS would be integrated into both the ship and the Aegis system, making it a permanent fixture. It uses advanced spectral beam combined fiber lasers, which offer better beam quality compared to LADUS's older laser setup. Moreover, HELIOS can dazzle drones as well as destroy them, providing a major boost to its combat capabilities. According to a white paper from Lockheed Martin, the HELIOS system has shown it can accurately hit fast-moving targets at long ranges. It was able to complete its targeting process using data from the Aegis combat sensor, after first tracking the target with both coarse and precise optical methods. The optical dazzling interdictor Navy is used in the system to interfere with enemy sensors by disrupting their electro-optical and infrared systems. While similar technology is found on other ships, the HELIOS program is the first to fully integrate this capability into a ship's command and control system. The laser weapon also includes a surveillance mission alongside its laser destruction and dazzling functions. The spokesperson chose not to disclose details about how its surveillance capabilities are being tested. They mentioned that the HELIOS is a multi-mission laser weapon system, and its missions, including surveillance, will develop over time as the Navy carries out at-sea operations and refines tactics, training, and procedures for this new capability. It's still unclear how the weapon will be used at sea. When asked if the Navy plans to install the laser on other ships, Lockheed Martin spokesperson didn't provide details. They, however, stated that the system can be adapted and used on other types of ships and combat systems. The Navy is interested in using laser weapons on different ships. Last year, they tested another laser system, the solid-state laser, technology maturation laser weapon system demonstrator, on the USS Portland. This system successfully disabled a drone during a sea test in 2023, proving the success of the laser systems on aircraft carriers. Now that the HELIOS system is ready, the next process involved the installation of the system through its paces after installation, with at-sea testing that was scheduled to start in 2023. The spokesperson noted that the Navy will gain valuable insights into the use of the HELIOS system in real maritime operations that started last year, and these lessons will guide future development efforts. They also mentioned that the laser completed land-based testing earlier this year in Wallops Island, Virginia. The main challenge ahead for the program will be integrating the system into the Navy's layered defense. They stated that integrating the laser into both the ship and its combat system, as well as ensuring its suitability for maritime conditions, is crucial for effective directed energy warfare. The system must function as a key part of a layered defense setup, like the Aegis combat system on DDG-51 class destroyers, and fit within the ship's space, weight, and power limits. While the laser is designed to meet these requirements for Arleigh Burke class ships, it would need to be adapted for other ship types or different combat systems. They added that its scalable and modular design architecture allows for such adjustments. According to the white paper, the system could be scaled up to 120 kilowatts or more, depending on the space and power limits of the ship. This includes potential future ships like the Constellation-class frigates and the next-generation guided missile destroyer, DDG-X. Sauer mentioned that the Navy is the most likely starting point for deploying laser weapon systems in the U.S. military because naval ships have ample energy supplies. However, he noted that fitting the laser on smaller ships presents significant challenges due to space and power constraints. As the United States develops laser technology, its rivals are also advancing. Although China and Russia don't currently have advanced laser systems like those in the U.S., lasers might become more common in various areas in the coming years, according to Mick Ryan from the Center for Strategic and International Studies. Ryan mentioned that while installing lasers on ships is happening now, seeing them used on land might take a bit longer. He also pointed out that Russia has claimed to use an experimental laser system called Zadira in Ukraine, though it's doubtful it has had a significant impact, as Russia often exaggerates its technology. However, the use of unmanned aerial systems in the conflict will likely drive technological progress. The Navy's laser weapon, along with other directed energy technologies from the Pentagon, like the Army's Directed Energy Maneuver Short-Range Air Defense System, can send a clear message to potential enemies, he explained. He added that the goal is to deter adversaries with these advanced technologies. However, if deterrence fails and a fight is necessary, it's important that these systems are effective in combat. However, the United States is not the only technologically advanced nation investing into the development of laser systems. Chinese defense officials are working on a Star Wars-style laser weapon for their nuclear submarines designed to shoot down British and U.S. spy satellites while staying hidden underwater. Chinese scientists revealed that the laser can destroy satellites and enemy aircraft in an instant because it fires at the speed of light. One of the targets they have in mind is the SpaceX Starlink satellite system, which can often be seen passing over the UK. The UK relies on about 7 military satellites for global command and control, while the US has 247 orbiting satellites. These plans were shared in the Chinese defense magazine Command, Control, and Simulation, where researchers explained that the laser could be mounted on a mast and fired at satellites, while the submarine remained underwater. The article explained that a submarine equipped with a megawatt-class solid-state laser could stay underwater while raising a retractable mast to fire at satellites, then dive back down after the attack. It stated that once a satellite is within range, the laser is activated, and after the strike, the submarine can submerge again and either wait for its next mission or return to port. Chinese sources claim that a laser would be much more effective than current anti-satellite weapons, which use ground-launched missiles with explosive warheads. The Chinese document also mentioned that the Starlink satellite network is dense and resilient, with many small satellites. Even if a large number are destroyed, replacements can quickly take over, making missile attacks inefficient. The article reported that satellite swarms are becoming vital in warfare, as seen in Ukraine, where they helped maintain communication for its forces after regular internet and satellite systems were destroyed. This highlights the need to destroy or disable many small satellites in low Earth orbit. China believes the answer lies in deploying fleets of mass-produced laser-equipped submarines, which could be sent to oceans worldwide to target these satellites. These laser subs could also help protect China's ballistic missile submarines from detection. The article explained that an escort submarine could use its laser weapon to disrupt or destroy enemy satellites, making it harder for space-based surveillance to track missile launches and thus keeping them hidden. However, some experts argue that developing a nuclear-powered laser submarine could still take many years. Chris Carlson, a former naval analyst for the Defense Intelligence Agency, explained that a submarine at periscope depth is not a stable platform for firing. He said that even a small movement in the submarine's position could cause the laser beam to miss the target. Carlson added that communication with a submerged submarine is challenging. After receiving an alert, the submarine would need to raise a mast with a data link to connect to the tracking sensor. Then, a separate tracking laser would need to find the target and aim the laser weapon correctly. He pointed out that many things could go wrong in this process. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.